All right. I know we have a lot more people that will be joining us, but in the interest of time and respecting everyone's time today, I want to kick things off today. Thank you for joining us. My name is Bill Griffin, and I am the professional development manager here at Informs. And today we have a very special guest, someone who has done some work with us, lots of work with us in the past, and someone who believe you'll have learn a little bit today, Polly Mitchell-Guthrie. And she'll be talking about lots of different things relating to the analytics process and making an impact, which I think goes beyond the math. I think is some of the things that Polly will be talking about today. So without further ado, I'm going to turn it over to Polly. Polly?
Great. Thank you, Bill. And I'm excited to be here today. I see lots of names on the participant panel. In fact, I see lots of you who could give this talk better than I could. So I'm delighted to see great folks here that are part of the conversation. I hope that we'll have some time at the end. I've planned it to have some discussion. So with that, I'm going to jump right in. So I don't think anyone needs convincing that AI and ML are big trends for 2020. This is one data point from Gartner, and what particularly got my attention is not that they named AI and ML one of their top trends for 2020, but that they predict that within less than 4 years, 75% of organizations are going to shift from piloting AI to putting it into operation. So what that really means is that this stuff is about to get real, because there's been a lot of playing in the sandbox. And so more than ever, as part of the pandemic, we're seeing an interest in companies and organizations trying to figure out better ways to do things, understand their demand, whatever's going on for them, and looking for advanced analytics as a way to do that. So I think we're going to see a lot more interest, and that's why trying to figure out how to make sure we have an impact is important. And that's because another thing that Gartner says is, based on various reports they've given over the years, anywhere between 60 and 85% of the projects will fail. And that's because there are lots of reasons they cite for why these kinds of projects fail. And so what we're going to talk about today are the things you can do to make sure you have an impact and prevent failure. But we're going to start off with a pop quiz. And that is because one of the things I've been doing since the pandemic is my company has been offering to give guest lectures on supply chain topics to universities who had to shift online. So we've been professors for a day to literally thousands of students. And so I'm going to take advantage of my opportunity to give a pop quiz. So what I'm going to tell you about here's how we're going to do this pop quiz. I'm going to show you that on the right in the picture here, we have 7 domains of analytics practice listed. And the way we're going to do the pop quiz, I've tried this several ways in my various Zoom calls. And the way that works best is to use the chat. So what I'm going to ask you to do, when I name the question, I've tried to give binary answers. And so I'm just going to ask you to type into the chat some of what you would do if you were shouting out. If we were live, I would have you shout it out, but get too much static on the line. So I'm going to ask you just to type your answers to the questions, and we're going to start to see where we are in terms of the answers. So the first question is, order of the domains matter? These are 7 domains. Does it matter? Are they in an order that matters? So just go into the chat and just say yes or no. All right, good. Lots of people answering. Let's keep going. Okay, somebody decided to try to see if it was a softball, but you all are clearly seeing this bit of a softball. We're going to get to the answers later. So next, this one's a little bit more of an opinion question. You can either answer with a number or the name, but the question is, which of these domains is the hardest? Okay, got some votes for business problem framing. Okay, more votes. Lifecycle management, deployment, model building. Okay, all right. Okay, good. And then next, which is the most time consuming? Change management, deployment, data. Keep going, more votes here. I'd cold call if we were live. You're lucky you're not live. All right, model building, data cleaning. Okay, analytics problem framing. Okay, good. And then last one, do all the steps really matter? Yes or no? That's a yes or no question. Okay, you're mostly seeing that's a little bit of a rhetorical question. Everybody understands I wouldn't be giving the talk if I didn't think they all mattered. So the point is, what we're going to do during the course of this talk today is talk about each of these steps, why they do matter, why the order matters, and then I'll give you my answers to some of these questions in the end. So here's what we're going to talk about. I like to give what I call the bluff, the bottom line up front. The key is following the entire analytics lifecycle. All the steps matter. How much time you spend on each may vary depending on your organization, your problem, but they all matter and they're critical to success. And I want to emphasize here, we're probably all geeks in some way, or we wouldn't be signing up for a webinar around analytics, but the math is just one part, and I'm going to really emphasize that point here. Before the math and after the math are lots of other steps, and they are very critical steps as well. And I'm going to share some stories to make them stick. I know everybody thinks it's the holidays here, so whether you're looking at lights because you're into Hanukkah or you're thinking of Christmas, I know it's not Halloween, but I'm going to share some stories to make it stick, and some of them are going to be scary stories to give you a perspective and help you really remember why each of these steps matter. But first, who am I? I'm going to tell you three things about myself. The first is that I understand there's snow in lots of places. I am fortunate that I live in Scottsdale, Arizona, moved here last year, so high of 64 today. Beautiful sunny skies out here. Second thing is that I work at Kinaxis, a supply chain planning and software company. So great space to be in. Love working in supply chain. A great year to be in supply chain. I came most recently as a practitioner from UNC Healthcare, where I led a team of advanced analytic practitioners trying to improve the delivery of healthcare, and I spent many years at SAS. Last thing to know is that I've been very involved over the years in two organizations. One is Women in Machine Learning and Data Science. I'm proud to say that I helped co-found the third chapter, and now there's over 100 chapters around the world, literally on 6 continents. So it's been a great organization to be part of, and certainly I've been very involved in Informs. And I'm going to talk about analytics certification in a minute, but I've also been involved in the Analytics Society, Edelman, nominating committee, a bunch of other things. And then finally, I'm a Tar Heel. Okay, so these are all the domains I mentioned before, and I'm going to tell you where they come from. And that is, for those of you who are not familiar, they come from the Certified Analytics Professional Program, which is aptly named because it's all about certifying people in analytics. What I want to tell you about these domains and where they come from is that in order to create a certification program, and I was involved in the initial task force many years ago, and then on the board for many years, chaired the board for a couple of years. So I'm passionate about this program because I think it really matters, and it is all about making an impact. But in terms of these domains and where they come from, and I'm going to show you the percentages of time that we believe roughly map to how much time an individual or an organization should spend on each step, it comes from a very rigorous process. In fact, we followed analytics in order to reach both which are the domains that matter and what are the weighting of the domains. We used psychometrics, which is all the analytics of measurement and evaluation. But we can talk about that more with anyone who wants more detail. But the point is that it's a rigorous process. We didn't just decide our opinions. We actually used an analytical process to say, if you're in analytics, what do you do, and roughly how much time should you spend on each area? And this is what we measure and follow in the certification process. It's on our exam and what I'll be talking about today. Okay, so we're going to start with Albert Einstein, who's always a great place to start. And I'd like to say that I love this quote from Einstein, because he says that if I had 1 hour to solve a problem and my life depended on the solution, I would spend the first 55 minutes determining the proper question to ask. For once I knew the proper question, I could solve the problem in less than 5 minutes. And I want to point out here, in case anybody's forgotten, Einstein was a physicist. So the point is, he's a very technical person, but what he's saying is that you have to frame the problem correctly, and then I figure out how to solve it. That's what matters. And so leads us to the first domain, which is business problem framing. Super critical, because what you really need to start with is, what problem are you being asked to solve? It sounds super easy, but it's not easy at all. Here's an example. I like to talk about the importance of separating interests from positions. Some of you may be familiar with this notion from the world of negotiations, and the reason I have an orange here is that it illustrates a simple way to illustrate what's the difference between an interest and a position. So classic story, 2 teenagers are in the kitchen, they're fighting over the one remaining orange in the house, and each is insisting that they are the one that has to have the orange. Their need for the orange is most important. They're yelling and screaming, and dad comes in and says, I'm going to settle this debate. He grabs the orange, he grabs a knife, he slices it down the middle, he hands them each half the orange and says, see, are you happy? It turns out neither one of them is happy because one of them, the boy, wanted the orange rind to do some baking, and the girl wanted some orange juice to drink. And so if they had only been able to communicate about their interest, I want orange rind versus I want juice, different than a position, I need an orange, they would have been able to come up with a better solution. So it's important to think about not just what are you saying you want, but how do you want to get there? Thinking about interests versus positions. And part of the reason why this matters, and I'll quote Jeff Cam on this, a professor at Wake Forest University, some of you may know, and a longtime practice-oriented academic, is that he likes to say that when you're talking to managers about what problem they have, they're often very good at telling you the symptoms or what their complaints are, but that's not the same as the business problem. So the reason that this step matters so much is that people are not very good at being able to articulate what their business problem is. They start out with the pain that they are feeling. And so the story I'll tell, this one's actually a happy ending story, which is why I like to tell it, to illustrate it. So it's what I call the subarctic oil problem. So 20 years after the Exxon Valdez oil spill, there was still a whole lot of oil in the waters off the Alaskan coast. And part of the reason the oil was still there is that when the water is cold, which let's face it, it's Alaska, it's always cold, it's too viscous, it's too thick to be able to use a pump to remove it very effectively. So they were still struggling with this issue. How do we remove the oil 20 years later? An organization called the Oil Spill Recovery Institute was brought in to try to say, how can we come up with some new solutions? Because clearly what we've been doing is not working. So what they did is they reframed the problem. They said, this is not an oil cleanup problem. This is a materials viscosity problem. And so they're trying to get novel solutions. So they actually had a competition and they said, what are your ideas for how we would solve this materials viscosity problem? They got many ideas, but the best one came from the cement industry. A chemist in the cement industry said, you know what you need to do? You need to vibrate that frozen oil and that'll keep it fluid. Think about those cement trucks you see. And you can even just modify it, commercially available equipment, and that will keep it from, that'll allow you to remove the oil. So the success of this problem was that they were able to reframe it from how do we clean up oil to how do we address the materials viscosity problem, the fact that the oil is thick when it's cold. Reframe the problem, you'll get better results. So another thing to think about when you're framing a problem is who are the stakeholders? And you need to make sure you talk to all the stakeholders and not just the executives who tell you this is the problem. I heard from a professor, Jan Francu, recently, who talked about the difference between what he calls the PowerPoint process and the real process. So what are people saying they're supposed to do versus what they really do? So you need to talk to all the stakeholders in the process, the people who are in the workflow and not just the managers. And you need to get clear on what are the business benefits for those stakeholders, what matters to them. And then you need to think about, is the problem addressable with analytics? It may not be. In fact, sometimes there's just a bad process in place and you need to figure out how to improve the process, but analytics is not always a magic solution. And finally, you want to iterate on that business problem. So you want to solve that, you state that problem and restate that problem and go back to your stakeholders and get clear on the benefits and then iterate on it again. So the story I give here is around readmission. So this is an example from healthcare. In healthcare, you don't want your patients to readmit after you're discharging them. And caseworkers are responsible for deciding when is a patient ready to be discharged. And there's at least two main reasons you don't want them to readmit. First, if they readmit, it's because their health is failing as soon as they leave, and clearly if their health is not good, you're not getting the right outcomes. And secondly, because if they readmit, depending on what program they're in, you may face financial penalties. So a big deal in healthcare is to come up with risk models to predict which patients are at risk of readmitting. I learned this story from a candidate in a job interview. Her team built a great readmissions model. It was highly accurate in terms of its predictive ability of which patients were at risk of readmitting, and it never got used. And the reason it never got used is they gave their model when they were done to IT. IT said, we're going to put it over here in this other screen, not in the main patient workflow that the caseworkers dealt with every day. The data science team said, we don't think that's a good idea, but IT said that's how we're going to do it. And the caseworkers, when they were asked to use it, said, you know what? We don't have the time to go over here and click on this separate screen in this separate place. We got too many clicks to get there. We don't have time to do that. We're not going to use it. Whether or not they had the time, at the very least, they didn't see enough value in that solution to make it worth them using. So the point is, stakeholders were not consulted, The model never got used. The problem was not framed correctly, and the no impact with that. That's why it's a horror story. Okay, analytics problem framing is next. So once you have your business problem framed, you need to restate your problem in analytics terms. When you're doing that, you need to figure out how to develop the drivers and the relationships to outputs and get clear on your assumptions. And then you need to define your metrics and ensure alignment. So this is really all about how do we abstract the problem, get clear on what the underlying structure is, and then consider whether it can be solved with analytics. In fact, one example I use also from healthcare is that when I went into healthcare, I had many people tell me I would face revenue management issues. And I thought, healthcare, I'm going to work for a nonprofit healthcare system. How am I going to face revenue management issues? But I quickly realized that the underlying structure of the problem is very similar to airline or hotel pricing and in terms of some of the components. So we looked at that underlying structure and used that as a way to think about how to frame the problem. Once you think you're clear on the problem as an analytics problem, you need to go back and reconfirm that stakeholder agreement. And I'll reiterate that you need to reconfirm this at many stages in the process so that you're always focused on making sure you're solving the right business problem. I can't emphasize that enough because each step you go, when you question your assumptions, you're going to learn new things. You want to make sure at every step along the way that every time you have dialogue, debate, rethink the problem, you're going to see it in a new lens, and that's a good thing. And it may seem tedious, but you need to go back to your stakeholders and say, okay, now that we've thought of the problem in this way, here's how we've tweaked our statement of what the problem is. Do you agree? And maybe their perspective has changed along the way, independent of what you've done. But I can't emphasize enough the importance of making sure you're continually go back to your stakeholders and say, here's the business problem as we see it. Do you still agree? The example I give here, and then again, this is another actual success story, I think. This is a production planning problem that I heard about recently solved in a novel way. And so this is, I have to be very anonymous about this one because I don't have permission to share it. So I'll give it in the most general terms, but this is a major manufacturing company that had to figure out how to plan their production. And basically, if you make lots of things, and make different kinds of things, you're going to have different production lines, meaning different like factory lines. And there's a cost when you switch from making, widget A to widget B, you need different parts on the line. And so you have to really think about how do you maximize the capacity of your equipment and minimize your downtime. And when you're making lots of things over lots of lines, it can get very complex very quickly. The classic way to solve this kind of problem would be an optimization model. That would be how most people would think about it, and it's certainly well studied in the literature. Only this company was having problems not only with the solve time, given the complexity of the number of inputs, but other factors. The mathematical optimization solution was not working for them. So they ended up reformulating it as a machine learning problem, and they ended up getting great results. They were able to compare to what they would have gotten with the optimization results. So the point is to not necessarily be set on what your analytics problem is. Production planning, most people would think optimization, but in this case, it was solved with machine learning. So get creative in terms of how you think about how you structure your problem. Okay, next step is data. Data is a big one. We all know that. Many people voted that data is a hard step in the process, and that's absolutely true. You may think you're swimming in data here, but what I want to say is that it can seem like data everywhere, but sometimes the answer is yes, data everywhere, not a drop to drink. You don't want to assume that just because you have data, that it's collected somehow. You just assume if it's collected, we must be able to get it in its raw form. Well, there are often ownership and extraction issues. So even just a simple example from my own company, we had a conference last couple of months ago, I guess, and because everything's virtual these days, I thought it'd be easy enough to get to which attendees. We did outreach to certain groups of academics. I wanted to see which academics were the sessions popular? How long did they watch them? Which ones were the most popular? I quickly learned that we could not get that live data. We could get certain canned reports from the vendor who managed the platform for us, but we couldn't get to the data, the raw data in the way I wanted, just to be able to do the simple analysis I wanted. Another example of this is in IoT. IoT is a big deal these days. lots of sensors. The thing that may not be clear to you is you may assume if you own the equipment and you have sensors on that equipment, that the data that comes off those sensors is your data. Not a good assumption to make. Or even if it is your data, you may have similar issues getting to it. Or even your challenges may be simpler even than this issue, and that is that often IT owns the access to the data. So in a healthcare environment where personally identifiable information is incredibly big deal, in the data science team I led, we did not own the data. We couldn't just go run a query and get the data we needed. We had to go to IT, tell them what we needed, and then get them to give us the data. And so ownership and extraction issues can be huge. And then the question is, do you have enough data? So this is a big failure rate. People assume, oh, let's just go do some machine learning on that data. But machine learning learns from data. So you need lots and lots of data, lots and lots of data. In general, for most analytical models, you need a significant amount of data, but for machine learning in particular, you need a lot of data. So this can be a real barrier. In fact, I crowdsourced some of the stories here, and one I got from someone named Luke who worked in a manufacturing environment for many years, as he quickly learned that he could have saved his customers a lot of time if he just started whenever they said they had a problem. He took his data scientists, went right down to the shop floor, helped them understand the problem. Think about that, that's business problem framing. Then they went to a whiteboard. They had to think about what was the structure of the problem. And then not even get to modeling until they learned if they had enough data, because he found regularly they had to go back to their stakeholders and say, we can't do that, there's an incomplete data set. So data really matters. In fact, data matters so much, I'm going to keep talking about data. So we all know the adage, garbage in, garbage out. Your model's certainly only going to be as good as the data that you have. And so there's lots more to this. Just because you have data doesn't mean you understand it. I've seen this issue be a barrier over and over again. I'm thinking of an example from Julie Ivey. Some of you may know Julie. She's a professor at North Carolina State University, built an excellent model around predicting sepsis, a very dangerous condition in healthcare. And among lots of the data they were dealing with, they were all these lab values, these vital signs. And one of the lab values had a range from 0 to, I believe it was 10 million, if I recall. And when they were initially looking at the data, they just assumed that given that huge a range, that there must be some errors. Part of what you have to do when you're dealing with the data is clean it up. And if you see a range that big, you just assume that there's some fat fingers there, too many zeros entered. But they talked with a clinician who said that in fact, in certain cases with that particular lab value, that indeed was the range. And so you can't know that on your own unless you talk to domain experts. And the more specialized the particular problem you're being asked to solve, the more this is an issue. And one of the reasons this is an issue is that domain expertise can often be a scarce resource. So for example, in healthcare, we often needed clinicians to be able to interpret the data for us, but they're busy seeing patients. They don't have time to meet with us. And they certainly don't have time when you're trying to do this, as we all are, you're in a hurry, you've got a short timeline, somebody's sitting there at 6 o'clock at night trying to figure this out, doesn't mean you can go get the doctor on the phone and get the answer to that question. So you have to plan in time to deal with the essential nature of the domain expertise. Then the obvious question to ask, if you're not familiar with this, is the data clean and ready? And the answer is pretty much, I'm gonna go out there on a limb and say the answer is never yes right away. You're never gonna have a clean and ready data set. Now, it used to be the case that an oft-quoted adage was data scientists would spend 80% of their time on data preparation. I'm seeing some data that actually suggests to me that number is going down. There's better tools out there to address this. The vendor Anaconda recently did a survey and found that data scientists were saying they spend 45% on their time on the data. But even if the data is clean and ready for analysis, you've still got lots of steps to go. So you have to do exploratory data analysis just to see what do you have going there. You have to transform your data. Just because you have a date stamp doesn't mean that you have something like time elapsed. You have to do some transformations, or what machine learning people like to call feature engineering, but you basically have to convert your variables in the form they come into something usable for analysis. So the point is that spending time on the data, can you get the data? Do you have enough data? Do you own the data? Do you understand the data? Is the data clean and ready? Data is a huge part of this part of this issue. So the story I tell here, and this is a horror story, has to do from my healthcare days. We were doing some analysis on our accountable care organization, and the one-liner on that is basically when you take responsibility from a risk perspective of a certain set of patients, and therefore you're accountable for their care from a financial perspective. And so we were doing some analysis on the first year of operation to see what had worked well, what hadn't worked well. In order to get that data, as I mentioned, IT owned the data, we did not. So we had to tell IT, pull this data set for us. Only it's not as simple as pull this data set. In order to understand what are the questions we needed to ask in order to get the exact right kind of, not just the variables, but the complicated to explain, but basically it was a complicated ask. We had to consult somebody else who gave us some advice, and these people were all, of course, you ask them a question and you have to wait 2 days to get the answer. Well, long story short, they gave us the data set, and Curry on my team spent days and nights, and I do emphasize nights. He literally spent several nights. We had a short turnaround time working on this until like 3 in the morning, and things started coming back funky to him. And he finally realized after days of working on this that the data pull had been wrong. And it wasn't that he was like missing a certain variable. It was that a particular way the query was sent gave him essentially mostly right, but not quite the right data set. So we had to go back to them and figure out what the problem was, get the right data set, and go at it again. So the point is that data is a huge issue, and do not underestimate the amount of time you're going to spend on data. In fact, I'll highlight here in the upper right, these numbers represent the percentages or the rough weighting of each domain. And data certainly is the domain that is considered to have the largest weighting because of the amount of time that you're expected to spend on. Okay, now we're going to talk about methodology. So here's a headline some of you may have seen recently about a particular biology problem that around compounds, that DeepMind from Google said that this is a huge breakthrough that they had in terms of their ability to have success looking at the shapes of proteins. And so I love this headline. It says that their progress in this particular area, that deep learning was going to change everything. I'm here to tell you deep learning will not change everything. And I don't mean to be cynical about deep learning. At least it's not going to change everything yet. And the reason I say this is that we always need to have the people pushing the frontiers of progress on the boundaries, and I don't mean to diminish in any way what DeepMind has done here. It is a phenomenal breakthrough. Deep learning is a fantastic technology, having adoption far faster than any of us might have guessed, but it's still not going to change everything overnight. And that's because, first of all, organizational maturity, in my experience, has been that most organizations are at the opposite end of the maturity curve, or even those that are farther up. Still, if we consider it, somewhere from 0 to 60 in terms of speed, most people are still trying to get into maybe second gear or even first gear. It's great that Google is out there going 100 miles an hour, and good for them. They're going to lead us all, but simple is almost always better. One of my favorite illustrations of this is from somebody I tried to hire many years ago. He was a practitioner in the healthcare space on both the payer side and the device maker side, and now he's teaching at NC State. I love this quote of his. He said I could use it. And what he did is he posted to LinkedIn saying, "Dear Ordinary Leaf Squares Logistics Cart, thank you for helping me pay my mortgage." And when I was chatting with him about it later, he said that he felt like he could stop his honors statistics class about 6 weeks in after he taught them these techniques, because they'd already learned about 90% of what they'd need to use for many years in their career. So the point is that Occam's razor, simpler is almost always better. It doesn't mean you're not going to use more techniques. We have a whole range of techniques, and we have a great toolbox. We should always consider that toolbox. But simple, when you're picking your methodology, is almost always better and should be your rule. And that's because you need to make sure you match the right tool for the right problem at the right time. I'm hiring an intern right now, and it's been interesting looking at the applications. One that stuck in my head was a undergraduate student in analytics or data science whose resume put in prominent letters that he was all about deep learning. And again, good for him. Maybe he'll go work for Google, but again, most of what he'll do most of the time for the next multiple years is likely to be simpler things. And that's because you want to have the right tool for the right problem at the right time. And when I say that, I mean, think back to my production planning example. Most people would think production planning is an optimization problem. In this case, they solved it with machine learning. You may have an answer that can give you more accurate results, but it may have other complications that mean that maybe the solve time is too long. Maybe it's too hard to explain. Whatever it is, accuracy, interpretability, solve time, complexity, all kinds of components go into what methodology you select. So right tool, right problem, right time. Just because it's trendy doesn't mean it's the right solution. You certainly want to look at your viable software tool options. And what I mean by this is that no matter what you want to use, you may be limited by budget. We were trying to do optimization problems in my last role, and we couldn't get budget to buy a commercial solver. So that limited us to open source, which those of you familiar with the optimization space will know that open source does not work in the optimization space in the same way it works in most of the rest of the data science domains. So yeah, maybe you're looking at a tool and you have to think about the one that your organization already owns, or maybe it's a tool that is easiest to hire talent for. Maybe it's the one that is easiest to explain. Whatever it is, the tool you use becomes part of your thinking in terms of how you consider your methodology. In terms of methodology selection here, the horror story I'll tell to stick in your head is one having to do with what I call the taxi problem. So again, back to accountable care. In healthcare, if you own a certain set of patients in terms of their risk, you may decide that it's worth it to you to pay some kind of service, and there actually is a service that's sort of like the Uber of healthcare, that you can pay to go pick up your patients and make sure they get to their appointments so that they don't miss their appointments for lack of transportation. An organization came to my team and asked us if we could help them predict which patients would be most benefit from this kind of intervention. They said, we have 50 patients that were in the program and we have 3 months of data. So some of you right away will recognize that 50 patients over 3 months, not enough to do any kind of rigorous analysis. The statistician on my team went back to them and said, we can't do anything. We can't build a predictive model with that. What you're really looking at is actually program evaluation, kind of like clinical trials. Did the intervention have an impact or not? So let me give you some tips on how you could do a simple program evaluation and then keep looking at that question over time. Unfortunately, they weren't very happy with that response that we gave them. And I later had them report to me that they'd found someone else who built them a machine learning model. And their machine learning model gave them a prediction. And what really broke my heart is that there are lots of reasons why a machine learning model was not the right solution. First of all, was highly unlikely to be able to give them any rigorous results. Just because someone knows Python code and can download a package and kind of plug and chug does not mean their results were useful. Did they know how to implement and deploy this model? Did they know how to maintain that model over time? And we'll talk more about these things. But the point is that in terms of methodology selection, machine learning definitely not the right approach to that particular problem. There were other approaches, but the person that they found who could help them was somebody who thought, well, machine learning is the kind of tool du jour. We're going to apply machine learning to any problem. Okay, so now we're going to talk about the math, the model building. This is the part that most people think is the most fun. So what you're seeing here is from a famous Google paper that they submitted at the NeurIPS conference a few years ago called Hidden Technical Debt in Machine Learning Systems. What you're seeing here is their depiction of an actual whole start to finish a machine learning system. And the reason I like to show this is because what you're seeing there is that little black box in the middle, that's the math. So you can see the math is only a very small part of the whole system when it's implemented. What that means is that there's a whole lot that has to happen before and a whole lot that has to happen after, and the math itself, the actual model building, is even a fairly small part. So I like to tell the people that math is rarely the hardest part when we're doing this, even when it's really hard, really complex math. If you're building, a recurrent neural network, and you've got your masks, your encoders, and all that fancy stuff, that doesn't mean it's going to be the hardest part. Your data scientists may have the most fun here. They may have solved a hard problem, but the things that come before and after are arguably harder. Another tip I give in terms of ensuring success with model building is that you ensure that you have sufficient rigor on your team. What I mean by this is that you want to have people who didn't just go plug and chug and learn how to, just because they can write Python code, as I said, doesn't mean they know how to interpret results. They know how to understand, was machine learning even the right model to use in the first place? Do they know how to compare and contrast this? You don't have to have a bunch of PhDs, but you also don't want people who took a few Coursera courses and haven't done algebra since high school. And one way to help with this is to consider a peer model review board. This is where the point is not necessarily to have a team that gets to vote on whether or not a model gets implemented, but at the very least, just like we might give a paper to someone else to read, can we have somebody else looking at our models to ask us questions, question our assumptions, question our interpretation of the results, question our approach, and have peers do this for each other. And you need to work at how do you figure out how to set this up so it doesn't seem draconian, but instead seems like something that helps. But you want to have things in place to make sure that your model building is rigorous and reviewed. So reason I have this picture here, I had a few people in my crowdsourcing point me to Gene Woolsey, who I never had the chance to meet, but longtime Informs member and professor who with a peer came up with this rule that people would rather live with a problem they cannot solve than accept a solution they would not understand. And the reason I highlight this is that interpretability matters. When you're trying to figure out what solution to offer, offering one that your end users will be able to understand matters a lot. So for example, in the regulated industries, this comes up as an issue all the time. I remember years ago hearing insurance customers tell me that they wanted to use neural networks, but the regulators didn't understand neural networks, so they had to use simpler models. Whatever your constraint is, you have to make sure that you pick models that your end users can understand. Now, the caveat I'll give to this is that I have seen cases where we don't need to run too hard on interpretability. I think there are times when, if we have insights we can get from some kind of analytical solution, and we can automate them, and it's not taking away somebody's job, and it's just taking away the mundane from them, they may not care how the results were received. Does your average user care how Siri works, or are they just happy when they try to dictate to their phone that Siri does a pretty good job using those machine learning models to give them to capture their speech into words? So it doesn't always matter, but you have to really consider whether or not it matters, and if it does, look for ways to illustrate it. One example I have here, I'm not going to really go into explaining this, but this is a SHAP diagram. Some people may know that Lloyd Shapley was actually an Informs member. This is a name for him. And what I'm showing you here is from a demand sensing model and in terms of demand forecasting. How can we look at other signals than historical data to try to figure out what impact it's having on our forecast? So the point is that we use an ensemble method, a variety of machine learning models may be coming up with a forecast. The black box may mean that we are not clear which model was used, let alone which features were most significant. But what we can show is in a fairly simple depiction that supply chain planners can understand which factors increased my forecast, which factors decreased it, so I can consider which signals I wanna look at. The story I give here is one a colleague told me about an e-commerce project. So she, in her company, the user experience team wanted some help trying to understand how to segment customers, and they asked the data science team to help. The data science team ran off, took the data, ran a bunch of unsupervised models for several weeks, threw back a bunch of clusters, said these are the personas, these are the clusters. And when the user experience researchers said, can you explain this to us and which features you used and why they mattered? They said, nope, we're done, we're busy, we've got to move on. These are results and you just use it. And so unfortunately the project was unresolved because the user experience team couldn't understand the results. The data scientists were not interested in a qualitative conversation with the researchers who actually understood something about the model. They had segmentation, they had domain experience that the data scientists didn't use. And so it wasn't, because of interpretability, their results were never used. It's a shame, but it happens all the time. Okay. Lastly, I'm going to talk about deployment. Deployment is a really critical stage. So IT, cannot emphasize this enough. In my experience, most of the time, the analytics teams are not part of IT. Sometimes they are, but even if they're part of IT, it may be a different part of IT. So cannot emphasize enough that IT is a critical business partner. You cannot, system integration matters. So Just like I gave the example earlier with the deployment with the readmissions model, where IT decided that we're going to deploy this model in a separate screen that requires our users to walk over here and click on this screen to get our results. Um, that didn't work for the workflow of the caseworkers, and yet IT has their reasons why they want to do things. And I get it, their job is to try to figure out what systems do we have available. So you need to really have your end users, your analytics team, and your IT all involved very early on, trying to think about how this stuff works. Because you can't just take your model, build it, and toss it over the fence. I've been burned this way myself. In fact, I'm thinking of one model we built, a patient optimization model, that I kept asking the question, is it going to be hard to integrate this into the electronic health record system? And I was told, well, if you can build a model, getting it into Epic, the health record system, is not going to be the hardest part. It turned out to be a very hard part. And it's not just IT isn't trying to be difficult. A lot of times these complex systems are hardwired in ways that don't give you the flexibility to change them. They can't input or extract data in the ways that you want. So you cannot underestimate deployment, and you have to think about this from the beginning. And you have to think about the end user workflow and adoption. If they're not going to, if it's not a model that's going to work for them, they will not use it. So deployment is just a huge, huge issue. The example I love to give here that just really illustrates this so well is from Netflix. This is an older example, so some of you may not have heard this, but back in the mid-2000s, they were really trying to figure out how to improve the accuracy of their movie recommendation model. How do we tell you which movie you're most likely to want to watch? And they worked on it for quite a while, and they said that we are going to pay $1 million to a team that can give us a 10% lift on our recommendation model. It's worth that much to us. So we'll pay $1 million. And they called it the Netflix prize. And so they had this competition running. There were, for $1 million, as you can imagine, there were lots of people interested in participating in the competition. There was a team that won. They gave out their $1 million, and they never used the algorithm. And in a famous blog, they ended up saying that the reason that they didn't use the algorithm was that the accuracy gains, and I quote them, the additional accuracy gains that we measured did not seem to justify the engineering effort needed to bring them into a production environment. So they basically said that the deployment costs weren't worth it for them. They didn't get enough gains to exceed the deployment costs. And then the other thing that happened, and this is why you need to iterate on that business problem framing the whole way along, is that they said that their focus on improving Netflix personalization had shifted to the next level by then. So in other words, their own business needs, essentially their business problem, had shifted. So they paid out $1 million for an algorithm that they never used as it was. Deployment, super critical. And finally, the last step in this process, the last domain, is model lifecycle management. So this is about making sure, you can build a great model, but your model's going to rust and degrade over time. I have to tell you that, no matter how beautiful your model is. So you need to make sure that your model is well documented, that you track that quality over time to see how it's degrading, and that you're monitoring and maintaining it in whatever way that is needed. And this also should be a consideration in your approach selection, because machine learning models, for example, not only are they complex, but they're more famously a little bit brittle over time, a little bit fussier, and so they need a little more monitoring and maintenance. So not simple, not only to deploy, but to maintain and monitor. The example here that illustrates this is from a former customer that I know with a revenue management problem. They were, this has to do with cruise ships, pricing for cruise ships. They had, they built a revenue management model to price the tickets. After about a month, they started, they were quite some time into using the model. And then they started noticing they were getting some funky results that made no sense whatsoever. So they dug into it, and it turned out the analyst who had built the model built it, but then deleted the seasonality factors because he didn't think they mattered. And he began doing manual adjustments instead, but he didn't tell anyone. So it wasn't well documented. Because he had left, people couldn't understand his code, didn't know what he'd done, it wasn't documented. The model started degrading, they were producing bad results. And it took him about a month to figure this out. And what the executive who told me this story said is that it probably cost them millions in that 1 month. And so even though this is the last step in the process and is weighted only 4 to 8%, it can be very costly if you don't figure out how to pay attention to this step in the process. So we want to get to a happy ending. We don't want to have horror stories. So won't surprise you to know that in terms of the quiz I asked in the beginning, all the steps mattered and they should be followed in order. Now that doesn't mean that, as I said, you may get to deployment and think, okay, well, the way we thought about deployment is going to change how we have to solve the problem, maybe the structure of the problem, maybe even how we frame the problem. So there will be iteration all along the way. You can't just start, assume you're done with a step and move on. You'll be iterative, but all the steps matter. Now, all the domains are hard. I will say that I did a poll out of my own curiosity a few years ago on LinkedIn, and I asked people what they thought was the hardest domain, and there was no clear answer. So what might not surprise you is many people thought it was business problem framing. It's certainly the most risky. You can do everything else perfectly, but if you have a beautiful process that solves the wrong problem, you're not going to have the impact you want. So risky, business problem framing is certainly a risky part of the process. Data is probably the most time consuming, and it's certainly a step that is one thing that's worth keeping in mind is it's typically not very satisfying for your data scientists. They're going to feel like they spend a lot of time at the more tedious step. It can be time consuming. They're relying on other people, and it's not the fun part to them. But you can learn a lot even in your exploratory data analysis, and that's worth remembering along the way. You absolutely need to make sure you're focusing on the right problem, because again, at the end of the day, you can have a beautiful solution to the wrong problem. And so solving the right problem really matters a lot. And then, my last statement on this is that cannot emphasize enough using the right math for the right problem at the right time, because just because it's trendy, just because it's easy, just because it's hard, just because it's what somebody knows how to do, the old story about the drunk who was looking for his keys under the lamppost, and somebody said, "Where'd you last have them?" And he points and says, "Oh, over here." And the person says, "Well, why are you looking under the light post?" And he says, "Well, that's because where the light's better." Just because somebody knows where the light is doesn't mean that's the right approach to the problem. You want to have the right math, the right problem at the right time. And that's because you do all these steps together. Nobody wants to go to work and at the end of the day feel like they didn't make an impact. So getting to impact is the happy ending. And the key to having an impact is following all these steps. So I'd love to have a discussion, whether we have one now with Q&A or whether you follow up with me later. I'd encourage you to connect with me on LinkedIn or Twitter. I love to have these kinds of conversations online as well as live now. So I'd be happy to take any questions. Thank you for listening.
Yeah, as I mentioned, thanks, Polly. Appreciate it. You can put them in the Q&A. Should be on the control bar. You'll see Q&A and just pop your question in there, and we can read them out. Polly, it's interesting when you said what's the hardest part. I think it depends also sometimes on who you're talking to. I think we've had a lot of practitioners, especially those going through the CAP process, that see maybe domain 5 because the tremendous breadth of it as maybe the hardest. But I think I've talked to program directors of universities that say probably number 1, probably business problem framing. It's the hardest thing to, and it's one of the most important. Like you said in the beginning, is making sure you're solving the right problem.
And that's a great point, Bill. And what it really highlights is the difference between what you learn in the great theory and foundation you can get from university or other kinds of educational programs, and the reality in practice. So it's absolutely hard to learn forecasting and optimization and statistics and econometrics and all those different domains. And from a studying from an exam perspective and being a student, certainly complex to have that breadth of knowledge. But the challenge is figuring out how to make sure you use the math in an effective way. And again, I can't emphasize enough, brilliant mathematicians who are ineffective if they can't go from soup to nuts in terms of this whole process.
We got a couple of questions coming in. I'm going to read the first one in the Q&A, and then I'll read another one from the chat. First one is from VJ, and VJ asks, what are some best practices for change management and user adoption, maybe from your perspective, Polly?
So great question, VJ, and you're absolutely right to highlight the fact that change management is critical. I'm thinking of one of the best examples I've heard of is the Orion project. Some of you may have heard. My friend recently retired Jack Levis from UPS, who led what Tom Davenport has called the largest analytics project in the world, and that is to essentially optimize uh, the routing and which packages they take for the UPS drivers every day. And as you might imagine, if you're telling a UPS driver, I know you've been driving this route 30 years, but trust me, my math model knows that I know it may seem funky that you turn here and then go here, but that's really the better way to go. The drivers a lot of times initially were like, you got to be kidding me. I know my route. That makes no sense to do that. So particularly when, optimization can give you very non-intuitive results. So they spent a lot of time on change management. They figured out how to find some of the leaders in the organization. They worked with the unions. They came up with kiosks that the drivers could see how this worked. They went with slow adoption and able to share the results. So what the commonality you're hearing there is that change management really involves dealing with your end users as well as your leaders. So you want to have the leaders singing the same song that you're trying to sing, and then making sure you're engaging your end users, your stakeholders in that adoption. So my best practice suggestion on that would be that you need to have a combination of executive leadership saying this is important and it matters, but you need to really listen to the voices of your end users or they will not adopt it.
All right. Another question from Shannon. Shannon asks, do you have any experience when you're not very familiar with the business of a client and they can't explain it well, or they don't have a good or right business problem to solve? If so, how do you solve it and better understand and do analysis for them? That's a lot.
That is a lot. So I see two parts here. One, Shannon, is that you're saying, what if you're not familiar with their business and they can't explain it well? I think you really have to emphasize to them the importance of, if you cannot understand their problem sufficiently, you cannot solve it for them. And so if they can't explain it well, obviously you're not going to tell them they can't explain it well, but who else could you talk to help you understand it? Now, one thing I'll emphasize about this, as important as it is to understand the business problem, one of the things that I worked with a great team of operations research or OR consultants a couple of jobs ago. And every time they worked with a new industry, the company would say, well, our industry is really unique. Our company is really unique. Our problem is really unique. You really have to understand this well. And they did. And yet they found that if they could sufficiently abstract the problem, you don't have to become an expert in product formulation or chemistry to be able to understand how to solve a problem that you've abstracted and then determined the proper structure for. So I would say it's important to not get too hung up on becoming an expert in, say, their industry or their problem, but making sure you understand enough to be able to articulate a problem that they agree is a problem. And then if they don't have a good problem to solve, well, then I would go back to your, really the first step of the process, business problem framing, and is there an analytical solution? If you can't articulate a problem that is the right one they want to solve and it's not amenable to an analytic solution, then you probably don't need to be there. I know you want to take, we all want to have good work and help people who feel like they have problems, but analytics is not always the right solution to a problem. And if they think otherwise, and a lot of people think analytics is going to be the magic bullet. I'm going to magically get all these people to work together because I'm going to give them a mathematical solution that's going to fix it all. And oftentimes it's really bad processing needs to be fixed.
Great, thank you for that. Have another one question coming in from the Q&A line from Andrea. Andrea asks, could you suggest some sources to learn or train for change management and user adoption? Anything you found?
Great question. I'm not an expert on change management sources, but what I would say is the classic is Cotter. Gosh, I can't think of Cotter's first name. I want to say it's Bill, but I'm not sure it's Bill. But Bill's a great name, Bill Griffin. But whatever it is, Cotter, K-O-T-T-E-R, is certainly John Cotter. There we go. John Cotter is certainly considered the classic leader in that area, and I would absolutely start with him.
Wonderful. All right, have another one from Slavo. Slavo asks, what are some of the best practices for attaining decision maker buy-in other than consultation at the stages of solving the problem?
So I think one of the things that matters is paying attention to the business benefits and the metrics. So you want to get their buy-in by not just stating the problem, but what benefits they'll get if you can solve the problem for them. And then you do want to make sure that whatever metrics you're choosing to measure the impact, that they match what they care about. You don't want to, you know, we've all seen this. You measure the wrong thing, you incent the wrong behavior, you get the solution in the direction that's not what you match. So you want to get them to agree that not only is this the problem, but here's the benefits you'll accrue. And if we get these benefits, you can't, of course, ensure that you will get the benefits, but if this problem can segment users in this way, and then you'll have a better way to tackle from there, do they agree that would help them? You know, people are people. That's the hard part. You know, that's where why I sometimes joke the math is the easy part. People are pesky. So you can't, you can't solve that problem per se, but the best thing to do is to try to get them aligned on what that business problem is, what the benefits will be, what you'll measure, and that they will get involved and support it if you can get there.
Great, and I know that I saw Bill Climack is joined us on here today. And I know Bill's done some work in that regard in practice. I know that we've had a lot of people who've shared some, including our one of our own, Patrick Noonan, who's worked on some strategies with regard to determining who is decision makers and how to go through that with the, you know, some principles around the black and green and white and red hats and assigning different roles to people based on where they are. So there's a lot of that in decision analysis, and I know that we've got some great sources out there for that kind of stuff. Another question can you suggest some good sources to learn more about business case formulation?
Gosh, it's a great question. I have some elsewhere. I don't have them in front of me. I don't know if there's a way, Bill, for me to send them to you.
Absolutely.
And for you to make them available for people afterwards, but I'll be happy to. They don't come, the actual citations don't come to my name, but I have seen some I'd frame, and I'm glad you're asking that question because it is, you're clearly getting the takeaway that that's a very critically important. And one thing I'll tell you about that I emphasize is that I've given a number of talks about this analytics lifecycle related to the certification process to universities on business problem framing, because what they have said to me is, one in particular came to me and said, you know, we're in the engineering program. We feel like we cover most of the rest of this pretty well, but our students don't, you know, they don't understand really how to frame a business problem. So can you help us? So I've actually given even a whole workshop on that, and I've got some resources I can suggest, but just not off the top of my head.
Yeah, and Polly, I'll back that up because on several occasions this year, we've had universities sort of reach out to Informs to say, we know you guys, you know, work in this space, and we understand that this is the first part of the analytics process. Our students sort of struggle with this business problem framing. So it sounds like you've sat in, what did you call it, a professor for a day, and provided some of those workshops. We've actually engaged with a couple of universities as well to bring that sort of knowledge to their students as well. So it's a very common question from
it's a great question
that happens in academia as well as in practice. So that's a great point, and something that I think we're at Informs anyway will look to help provide some of that learning to the community, and whether that's working with Polly or others, we'd love to sort of challenge or tackle that problem. That's all of the questions that we have, which I think were great, and we're only 1 minute over. So as Polly mentioned, you know, she'll send over to me some of those sources that she can cite. I will send this. I will send a follow-up message back either today or tomorrow with a link to the recording in case those of you who missed it or want to look back or want to, you know, see something or remember something from this that would be great for you and your business or your practice. And then we'll send off those sources as well, and any follow-up information. And with that, I'll say thank you all for joining us. We really appreciate it. Thank you, Polly, for another great talk. And thank you to everyone. And I hope everyone, at least in the Northeast, that's about to get hit by a big snowstorm, is safe and hunkered down. And those like Polly that are enjoying 65-degree weather, I hope you have a great day as well.
Thank you. Thank you, everyone. Bye-bye.
Bye-bye.